June 3, 1998. Germany. A high-speed train slices through the countryside at 200 kilometers per hour, carrying 287 passengers toward their destinations. It's a symbol of German engineering excellence, a marvel of modern rail technology. In exactly 7 minutes, it will become the site of the deadliest high-speed train disaster in history. This is the story of Eschede, where a single defective tire turned a routine journey into a nightmare and revealed that even the most advanced systems can fail in the most catastrophic ways. The Intercity Express, known as ICE, represented the pinnacle of German railway achievement. Introduced in 1991, these sleek white trains were designed to compete with air travel, reaching speeds of up to 280 kilometers per hour on specially built tracks. They were comfortable, punctual, and considered among the safest trains in the world. The German public trusted them implicitly. On June 3, 1998, ICE 884, named the Wilhelm Conrad Röntgen after the famous physicist, departed Munich at 5:30 a.m. bound for Hamburg, a journey of approximately 800 kilometers. On board were 287 passengers, families heading home, business travelers, tourists exploring Germany, and students returning from trips. The train consisted of 14 cars pulled by a power unit, equipped with the latest safety systems and technology. Among the passengers was a group of schoolchildren, elderly couples, and working professionals. Most settled into their seats, expecting nothing more than a comfortable 6-hour journey through the heart of Germany. The ICE trains used a revolutionary wheel design. Unlike traditional train wheels, which are solid metal, the ICE wheels incorporated a rubber tire between the metal rim and the hub. This design was intended to reduce noise and vibration, making the ride smoother and quieter for passengers. Each wheel consisted of 3 components: an inner steel hub, a rubber dampening ring, and an outer steel tire. The rubber layer was supposed to absorb vibrations and reduce wear on the tracks. It was an innovation that seemed brilliant on paper, but it had a fatal flaw. The rubber rings were subject to metal fatigue where they connected to the steel components, and the train's inspection procedures weren't rigorous enough to catch microscopic cracks before they became catastrophic failures. On the morning of June 3, 1998, one of these wheels was already damaged. A crack had formed in the rubber layer of a wheel on the first passenger car. No one knew it was there. No alarm sounded. The train left Munich on schedule, and for hours, everything seemed perfectly normal. At 10:54 a.m., the train was traveling through Lower Saxony at approximately 200 kilometers per hour, just 7 minutes from its scheduled stop in Eschede. Passengers were reading, chatting, enjoying coffee in the dining car. Some were gathering their belongings, preparing to disembark. Outside, the German countryside rolled by. Fields, forests, small villages. Then, without warning, something went wrong. The rubber tire on one wheel of the first passenger car failed. The outer steel ring broke loose and began to separate from the wheel hub. At 200 kilometers per hour, this created an immediate and catastrophic mechanical failure. The loose tire fragment dragged along the track, creating sparks and a terrible grinding sound. Passengers in the first car felt a sudden vibration, heard an alarming noise. Some stood up, trying to understand what was happening. Others moved toward different cars, sensing danger, but not yet understanding its magnitude. For approximately 2 kilometers, the train continued forward, with the damaged wheels scraping and bouncing along the track. The loose tire fragment was being pulled along beneath the car, striking the track bed, throwing debris. Then, at 10:59 a.m., near the small town of Eschede, the disaster reached its inevitable conclusion. The broken tire fragment acted like a wedge, forcing the train wheels off the rails. The first passenger car derailed, lurching violently to the side. The derailment propagated backward through the train at tremendous speed. Cars jackknifed, twisted, and began to disintegrate. Passengers were thrown from their seats, slammed against walls and ceilings, caught in a maelstrom of breaking glass and tearing metal. And then came the bridge. Just ahead of the derailing train stood a concrete road overpass, a simple structure carrying a local highway over the railway tracks. As the derailing cars approached, still traveling at tremendous speed, they struck the bridge's support pillars with the force of an explosion. The impact was so violent that it sheared through the concrete supports. The entire bridge structure, weighing hundreds of tons, collapsed onto the train. Massive concrete beams and steel reinforcement crashed down, crushing the passenger cars beneath them. The sounds were apocalyptic. The screech of metal tearing, the thunder of collapsing concrete, the screams of passengers trapped in the wreckage. Train cars that moments before had been traveling at 200 kilometers per hour were now compacted, twisted masses of steel and concrete. Some cars were crushed to less than a meter in height. Others were torn completely apart, their contents, luggage, seats, passengers, scattered across the tracks and surrounding fields. The destruction stretched for several hundred meters along the railway line. The lead power car had somehow remained on the tracks and continued forward for nearly a kilometer before the engineer, feeling the sudden loss of weight, brought it to a stop. Behind it, the trailing cars, which had not yet reached the bridge when it collapsed, remained relatively intact. But the middle section, the cars that had struck the bridge, were obliterated. Of the 14 cars, 5 were completely destroyed. The bridge itself was gone, reduced to rubble lying across the mangled remains of what had been a modern passenger train. The entire catastrophe, from the moment of wheel failure to the final settling of debris, had taken less than 5 minutes. The silence after the crash was brief. Then came the screams. Survivors in the rear cars, shaken but alive, stumbled out onto the tracks, confronted with a scene of unimaginable horror. The front section of their train had disappeared beneath a mountain of concrete and twisted metal. Those who could move began pulling at debris, trying to reach the trapped passengers whose cries could be heard from within the wreckage. Local residents in Eschede, a quiet town of just 7,000 people, heard the terrible sounds of the crash and came running. What they found was beyond their worst nightmares. Emergency calls flooded in. Within minutes, every ambulance, fire truck, and police vehicle in the region was racing toward Eschede. But nothing could prepare the first responders for what awaited them. Firefighters arrived to find hundreds of tons of concrete pinning down train cars filled with victims. Some passengers were visible, trapped and crying for help, but unreachable beneath the debris. Others were silent. The bridge deck, which had been a smooth roadway minutes before, was now a chaotic pile of broken concrete slabs resting atop crushed train cars. Rescue workers had to work carefully. Shifting the wrong piece of debris could trigger a secondary collapse, killing both victims and rescuers. Heavy equipment was brought in: cranes, cutting torches, hydraulic spreaders. But the work was agonizingly slow. Each piece of concrete had to be lifted carefully.
Each section of mangled train car had to be cut apart with precision. And with each layer removed, rescuers found more victims, some alive, many not. The rescue operation continued through the night and into the next day. Floodlights were erected, turning the crash site into a surreal landscape of shadows and harsh white light. Medical teams set up triage stations. Helicopters evacuated the most critically injured to hospitals across the region. The German military was called in to assist. Volunteers arrived from surrounding towns, bringing food, water, blankets. But despite heroic efforts, the death toll continued to climb. By the time the last victim was pulled from the wreckage days later, 101 people were dead. Another 88 were seriously injured, many with life-changing trauma. It was the deadliest train accident in German history since World War II, and the worst high-speed rail disaster the world had ever seen. The nation was in shock. How could this happen? The ICE trains were supposed to be the safest in the world. German engineering was supposed to be flawless. Within hours, every ICE train in Germany was ordered to reduce speed or halt operations entirely, pending inspection. The media descended on Eschede, broadcasting images of the destruction to a horrified public. Families of victims arrived, desperately searching for information about their loved ones. Makeshift memorials appeared, covered with flowers, photographs, and messages of grief. Chancellor Helmut Kohl visited the crash site, his face reflecting the national trauma. This wasn't just a technical failure. It felt like a failure of the systems and institutions Germans had trusted implicitly. Questions demanded answers. Why had the wheel failed? Were there warning signs? Could it have been prevented? The German Federal Bureau of Aircraft Accident Investigation took charge. Though this was a train disaster, their expertise in catastrophic failure analysis was needed. Teams of engineers descended on the wreckage, carefully documenting every detail, every twisted piece of metal, every crack and fracture. The damaged wheel that had started it all was located in the debris field, its fatal flaw now obvious in the light of tragedy. Investigators also examined maintenance records, design specifications, and inspection protocols for all ICE trains. What they discovered was damning. The rubber-ringed wheel design, which had seemed so innovative, had a fundamental weakness. The connection between the rubber layer and the metallic components was subject to fatigue failure, especially at high speeds and under the constant stress of heavy loads. Microscopic cracks would form and propagate until the rubber ring suddenly failed. Worse, these cracks were difficult to detect through visual inspection alone. The wheels needed sophisticated testing to identify potential failures before they became catastrophic. But the inspection protocols for ICE trains didn't include such rigorous testing. Visual checks were considered sufficient. The assumption was that any significant defect would be obvious to trained maintenance personnel. This assumption proved fatal. Records showed that wheels with similar fatigue patterns had been noted on other ICE trains, but had been deemed acceptable for continued service. Warnings from some engineers about the rubber ring design had been dismissed or downplayed. The focus had been on keeping the trains running, maintaining the schedule, upholding Germany's reputation for efficient rail service. Safety concerns that might have grounded the fleet for extensive testing were seen as excessive caution, and so the trains continued to operate at 200 kilometers per hour, carrying thousands of passengers daily, running on wheels that were slowly failing. The investigation revealed another troubling fact. After the wheel failed on ICE 884, there had been nearly 2 kilometers and more than a minute of warning before the final catastrophe. If the train had been equipped with better sensors, if the brake system had been designed to respond automatically to wheel anomalies,
If the emergency communication systems had been more responsive, the train might have been stopped before it reached the bridge. The disaster was not just about a faulty wheel, it was about systemic failures in design, inspection, and emergency response.
The human cost of these failures was devastating. Among the 101 dead were entire families, a mother and her 3 children traveling to visit relatives, an elderly couple celebrating their 50th anniversary with a trip, university students heading home for summer break, business professionals returning from conferences. Each victim had a name, a story, a future that ended in the wreckage at Eschede. The injured faced months or years of recovery. Some lost limbs. Others suffered traumatic brain injuries. Many would carry psychological scars for the rest of their lives. Survivor's guilt, PTSD, a permanent fear of train travel. The town of Eschede, population 7,000, was forever changed. Nearly every resident had participated in the rescue effort or knew someone who had. The community came together in grief, supporting each other and the victims' families. But the trauma lingered. The crash site became a memorial, a place of pilgrimage for those seeking to understand or remember. For the rescuers, firefighters, paramedics, police officers, volunteers, the memories were particularly haunting. Many required psychological counseling to cope with what they had witnessed. The images of crushed train cars, the sounds of victims trapped in the wreckage, the knowledge that despite their best efforts, so many had died, these things don't fade easily. One survivor, Claudia, who had been traveling with her young daughter, later described the moment of impact. Everything went silent. Then the screaming started. I couldn't find my daughter in the darkness and the twisted metal. I thought I'd lost her. She eventually found her daughter, injured but alive, trapped beneath the seat. Together they survived, but Claudia never rode a train again. Stories like hers multiplied, each survivor carrying their own version of the nightmare, each family of the deceased left with an absence that could never be filled. The official report was released in 2000, 2 years after the disaster. Its conclusions were clear and unsparing. The primary cause was the fatigue failure of the rubber-damped wheel. Contributing factors included inadequate inspection procedures, design flaws in the wheel assembly, and insufficient emergency response systems. The report made numerous recommendations, but the damage to public confidence had already been done. The rubber-damped wheel design was immediately abandoned. All ICE trains were retrofitted with conventional solid steel wheels. Inspection protocols were completely overhauled, with mandatory ultrasonic testing and more frequent wheel replacements. Speed restrictions were implemented on certain sections of track where bridges or other structures posed additional risks. Emergency braking systems were upgraded to respond automatically to wheel anomalies. But perhaps the most significant change was cultural. The Eschede disaster shattered the assumption of infallibility that had surrounded German engineering. It demonstrated that innovation without adequate testing and oversight could lead to catastrophe. It showed that efficiency and speed could not be prioritized over safety. These lessons extended beyond Germany. Railway systems worldwide reviewed their own high-speed train designs and safety protocols. Japan's Shinkansen system, France's TGV network, and emerging high-speed rail programs in other countries all implemented additional safety measures in the wake of Eschede. Legal proceedings dragged on for years. Several Deutsche Bahn officials and engineers faced charges ranging from negligent homicide to breaching safety regulations. In 2003, a court case began against two engineers who had been involved in the wheel design and approval process. But the trial was complicated. Determining individual responsibility in a systemic failure proved difficult. Eventually, many charges were dropped or resulted in suspended sentences. For many victims' families, this felt like justice denied. How could so many people die and so few be held accountable? Deutsche Bahn, the German rail operator, paid millions in compensation to victims and families. But money couldn't restore what was lost. The company's reputation suffered enormously. Ridership on ICE trains dropped significantly in the years following the disaster. It took nearly a decade for public confidence to fully recover. Even today, many Germans who remember Eschede feel a moment of unease when boarding a high-speed train. The psychological impact of the disaster extended far beyond the immediate victims. Memorials were established, both at the crash site in Eschede and in other locations. A memorial service is held annually on June 3rd, attended by survivors, families of victims, and rescue workers who were there that terrible day. The town of Eschede built a memorial garden, a quiet place where visitors can reflect on the tragedy and remember those who died. Plaques list the names of the 101 victims. Trees were planted, one for each life lost. It's a peaceful place now, though the railway line nearby still carries trains, slower now through that section, with better wheels and more rigorous safety systems.
The legacy of Eschede lives on in railway safety protocols worldwide. Every high-speed train system has been influenced by the lessons learned from that disaster. Wheel designs are more conservative, inspection procedures are more rigorous, emergency systems are more responsive. And perhaps most importantly, the culture of safety has changed. No longer is efficiency assumed to be compatible with safety. Safety comes first, always, even if it means slower speeds or more frequent inspections or higher costs. On June 3rd, 1998, a routine journey became a nightmare because of a single failed component, a rubber ring in a train wheel. But the real failure was deeper than one defective part. It was a failure of systems, of oversight, of the assumption that German engineering could never fail catastrophically. It was a failure to listen to warnings, to prioritize safety over efficiency, to imagine that the unthinkable could happen. 101 people died because of these failures. 88 more were seriously injured. Countless others, survivors, rescuers, families, friends, carry the psychological scars of that day. And an entire nation learned that even the most advanced technology, even the most trusted systems, can fail in the most devastating ways. The Eschede disaster stands as a reminder. In engineering, in transportation, in any system where human lives are at stake, there is no room for complacency. Every component matters. Every inspection matters. Every warning sign matters. Because sometimes a single overlooked flaw can cascade into catastrophe. The trains still run through Eschede today. They're safer now thanks to the lessons learned through tragedy. But they pass slowly through that section of track as if in remembrance. And on the anniversary each year when the trains pass the memorial garden with its 101 trees, conductors sound their horns, a moment of respect for the lives lost, and a commitment to never forget the price of that terrible lesson. The broken wheel that started it all sits in a laboratory now, preserved as evidence and as a teaching tool for future engineers. It's a simple object, steel and rubber, weighing perhaps 50 kilograms, but it changed history. It ended lives. It revealed the fragility beneath our confidence in technology. And it taught us that in the pursuit of speed and progress, we must never forget that safety is not just a priority, it is the only priority that matters. For 101 people, June 3, 1998 began as an ordinary day. They boarded a train, trusted in German engineering, and never arrived at their destinations. We remember them, we honor them, and we continue to learn from their loss so that such a tragedy never happens again.